I'm not sure if you're familiar with dynamic programming. It's a top-down approach of a recursion. So this is more like an advanced topic, but you'll usually have to use this to solve problems like minimum or maximum. Yeah, you're given an integer array coins representing coins of different denomination and an integer amount representing the total amount of money. Return the fewest number of coin that you need to make up the amount. If that amount of money cannot be made up of any combinations, return -1. You may assume that you have infinite number of each kind of coin. So for example, 1 to 5 amount is equal to 11. So in this case, you have 5 plus 5 plus 1 equals 3, right? So you have 3 number of coins. That's the minimum. So usually that's a hint, like if you're trying to solve like minimum or maximum, usually you need to use some sort of dynamic programming to solve for problem. Yeah, it says that there's an infinite amount. So you could create 1 1 1 1 1 and then 1 2 1 1. So basically you have to do a lot of combination to get that amount. So and then you need to solve the minimum, right? It's not just like 1 1 1 1 1. Obviously you need 11 coins of 1 to get to 11. But that's not the minimum. The minimum is 5 5 1. But for this example, bottom-up approach, which is dynamic programming, we'll start with the base where, like, let's say you only have 1 coin, which is 1, and the amount that you need is 11. So to give you a better example, like in this case, so you have 1 2 5, you have 5 coins and your target is 11, right? For the amount 11, how many 1 coin did you need? And that answer is 11. So let's assume that our target amount is 11. So we can create, like, if your target amount from starting from 0, 1 2 3, oh, this is your target value, 8 9 10 11. When you have a, let's just assume that you only have 1 coin, which is 1. If you only have 1 coin, how many coins do you need to get to 0? And that is 0, right? How many coins do you need to get to 1? That is 1. How many coins that you need to get to 2? That is 2. And so on and so forth. And 3. That's the most minimum number of coins that you need. 5 6 7 8 9 10 11. So yeah. Now let's say you have 2 coins, right? You have coin number 2. So basically you have to apply the same stuff of coins. So these are the minimum number of coins. You have only 1 coins. Now what if you have 2 coins, which is 2 now? Obviously this will what return 0, but skip this one. Copy it as it is. 0 1, copy it as it is. So we start with 2. Because that's where your minimum coin for 2 is. Now you have coin 2. How many coins do you need to get to 2? That's 1, right? How about 3? How many coins do you need to get to 3? So you basically 3 minus your coin, which is 2, plus 1, which is your remainder. And that is 1 plus 1, that is 2. How many coins do you need to 4? That is 2 plus 2, which is 2. How many coins do you need to go to 5? That is 2. That is 3. 3 plus 1. Because 3 plus 2, which is 2 plus 1, which is 3. 6 is 3 plus 3, which is 6 minus 2 is 4, which is 2 plus 1 is 3. 7. 7 minus 2 is 5. 3 plus 1, which is 4. 8 minus 2 is 6. 3 plus 1 is 4. 9 minus 2 is 7. 4 plus 1 is 5. 8, this is 5. And 11 is 6. 11 minus 2 is 9, plus 1 is 6. Yeah. So you need at least 6 coins if you have 2 coins minimum. That is because these are all the minimum coins that you need. Now let's try if you have a coin number 5. Coin number 5, you start, again, you copy this one. Copy this one. 2. You start with 5. How many coins do you need to get to 1? Obviously it's 1, right? Because if you have, the value is 5, if your target is 5, you only need 1 coin. If the target is 6, how much is it? So basically 6 minus 5 is 1, right? Let's give you 2. 7 minus 5 is 2, plus 1 is 2. 8 minus 5 is 3, plus 1 is 3. 9 minus 5 is 4, plus 1 is 3. 5 minus 5 is 5, plus 1 is 2. 11 minus 5 is 6, 2 plus 1 is 3. So the answer is 3. The last, basically you get the last in the table. Yeah. Normally the top-down approach requires you to store the result in the table. In this case, we're storing the amount, right? And that's it. This is your, yeah. It sounds counterintuitive, but this table is like your minimum amount of coin for each of the iteration of the coins and for each of the value. So basically all we really need to do is do 2 for loops, a cross multiply between 3 coins times amount, starting from yeah, sounds pretty straightforward, right? So let's try to code this out using maybe we can use Golang here and then try to write it up. We need like a table, which is I mentioned a while ago. So you need to create a table. We call it a DP. It's equal to make the okay, length is n is len points. Oh, plus 1. No, sorry, it's amount. Amount plus 1. So your table is all the amounts from starting from 0 to. So this would be n, and then yeah, we can start a for loop for each of the coins. That's what we did a while ago. For each of the coin, which is let's just call it it's called coins, and then for each of the amount. Now your amount starts from the coin position, which is I is less than amount equal then I plus plus. So what would be the value for this index for I? TPI. Okay. So we're doing a minus sum here. If you notice, like the sum is I minus A. Right. This is your complement. Your complement. If my amount is 1 and my coins is 1, you basically subtract it. Yeah. So let's say if your amount is 6 and your coin is 5. So what you want is 6 minus 5 is equal to 1. So basically 6 is equal to 5 plus 1, right? So what we're doing here is 6 minus 5, which will give us, we're gonna look up 1 here because 5, we know that 5 is the coin that we have, which is always results to 1. 5. Okay, so this is the complement value, and then we add 1 additional coin because it's always additional coin plus 1 because, for example, these are the coins that we're passing through, right? So basically we need to find the minimum, and to find the minimum is if dp is greater than r, you basically assign dpi to r. That's how you do that. And then you remove this. Okay. And then I think we need to initialize our DP with infinity. Right? Range DP, and then for each of the DP we assign n, and then DP we assign it to 0. Right. Okay. You can return the result here. So how do you know if it's not because we're doing a min here, right? So if DP is still the original amount, which is n, then we know that it wasn't touched, right? If DP amount is equal to n, I should make this like this, then return -1, else return DP amount. Yeah, you can try to run this, see if it's gonna work, because it says here that you return negative, you cannot calculate it. Coins as value range, sorry. Okay, submit it. Yeah, it works. So yes, this is how you actually solve this. So basically multiplying each of the coin all the time and then calculating the mean. Yeah, so calculating the mean using complement. Coins. Yeah. Why we need to assign it to this? Because 0 is actually a valid number, right? It's a valid that you cannot compute it. So the best approach is to assign it to an infinity number, which is something like this. Yeah, and that's basically how you do this computation here. Yeah, so yeah, if you like this video, you can hit like and subscribe. See you in the next session. Thank you for watching.